All right, 3.3, transformations. Remember, transform just means changes. So we're going to be taking the parent functions and changing them. So number one, notice it says graphing calculator. So you're going to be using this. You should be practicing this. While you're doing those, if you have access to a graphing calculator, you should practice this. Or, in class later, practice with these. Okay? So we're first doing y equals absolute value of x. And when I say y, it's the same thing as f of x. Okay? So we go to y equals, and for absolute value, we hit math, go over one number, and there's absolute value. Now we're just going to put an x in there. That's it. And we're going to graph it. And that's a really easy v, okay? And if you look at the table, everything is, negative 3, 3, positive 3, 3, negative 2, 2, positive 2, 2, negative 1, 1, 1, 1, 0, okay? So that's a really easy one to graph, okay? It's pretty much just y equals x, like here, and then on the opposite side going that way. All right, that's your parent function. Now we're going to put this in and see what happens to it. So I'll put this in the second one so you can see what happens. And I suggest you do this to help you understand what's going on. Always put the parent function in 1 and put the transform 1 and 2. So here we go. So we're going to hit absolute value again. So math, number, enter. And we're going to type the x plus 5 in here. And the plus 2 is going to come out here. If we didn't put it out, it would just basically be x plus 7. Now we're going to hit graph. And look what happened, okay? It moved left and up. So let's see where the graph is now. So the first one is 0, 0. The second one is 0, 7. Okay? And 3, 3 became 3, 10. That's the edge of that one. Now let's see where it bottoms out. Let's see, negative 3 and 4. That's right there. Let's go up a little bit. Negative 4, 3. Negative 5, 2. And that's where it bottoms out because you can see it starts going back up again. So negative 5, 2 is right here. And then if you look at negative 6, it's negative 6, 3. And it's going to start going back up again. And so the V is right here, like so. So what did it do? It moved left 1, 2, 3, 4, 5. Every point, I'm starting at the vertex. So it moved left 5, and it went up 1, 2. You can choose any point. The vertex is just the easiest one right there. Okay? So, on number 2, y equals x squared. We're going to clear that out. X squared. Oops. X squared. Clear this out. I'm just going to put the other one in at the same time. So parentheses, x minus 3. Close parentheses. Squared. So here's my happy parabola. Here's my new one. Something wrong. Oh, I forgot the minus 5. Silly me. Let's try it again. Here's my happy parabola. Here's my new one. All right. So the first one, you could look at the graph on the table. I know what they are. So it's 0, 0, negative 1, 1, 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. And that's your happy parabola right there. All right. Now let's see where the other parabola is. So, a lot of these numbers are off the chart in that third column. So we're going to go to where we could hit. And 4 is the best. So 0, 4. One, negative 1. 2, negative 4, and 3, negative 5. And then it starts going up again. 4, -4, 5, -1. And then 6 is going to be right up here matching that other blue point. And there's my happy parabola that has just moved. Like so. Now, going back from the origin, the vertex, okay, what did it do? It moved right 1, 2, 3. And it moved down 1, 2, 3, 4, 5. Maybe see where these numbers came from? Right 3, down 5. Left 5. Up 2. We'll get more into that. All right. Square root of x. So again, going to our y equals. Clear out what we have. And we have the square root, so second square root x. And then we have, notice there's a little negative in front, so be careful with that. Negative second square root, didn't get it. Negative second square root. Now x minus 4 goes underneath, and I have to arrow out to put the plus 2. Otherwise, it will combine those. So let's go ahead and graph this. So there's my parent function, and there's my other one. It's kind of hard to see, but let's go into the table. So for the first one, we have 0, 0, 1, 1, and 4, 2, which makes sense. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And the other one will be square root of 9 is 3. And that is the square root function right there. Now, the next one is kind of hard to see again. So notice all these errors. So the first one we have is 4, 2. And then 5, 1. So 4, 2, starting at the same point there. And then 5, 1 right here. Let's see if we can get another whole number. That's 7, 8, 9, or 10. And there we go. We have 8, 0. So this one goes like this. So what happened here? Well, for one thing, it's flipped upside down. It's flipped over. That's what this negative here does. Okay. It also moved 1, 2, 3, 4 to the right. That's right here. And it moved up 2. And that's right there. Okay. Next one, we have an exponential growth function. So we have the base of 2 raised to the power of the x. For the second one, we have 2 raised to the power. Now, be careful. Notice the x plus 3 is up top. So we type in x plus 3. Then we arrow over to come down to put the minus 6 in. And here we go. So there's our parent function, 2 to the x. And here comes our transformed one. Let's go to our table. So you have a lot of decimals here. So I'm going to start at 0, 1. That's the easiest one right there. And then 1, 2. And then 2, 4, and 3, 8. And basically that means 2 to the 0 power, 2 to the first power, 2 to the third power is 8. And this is what it looks like. But it bottoms out. It never hits 0. So you want to do your best job to kind of ride that out. And if you notice the calculator, when you graph that, you can't see anymore, but it kind of almost like blends in with the line, but it actually technically is never hitting 0. You'll see it gets smaller and smaller. Now eventually the calculator will error out, but you can see, now it's using scientific notation, really tiny. But eventually, sometimes it does error out. But I'm all the way at -30, And it hasn't yet. So now notice though on the second one, how it keeps saying -6, and we'll talk about that. It actually never touches -6. So that is an error right there on the calculator where it can't handle it. Okay. So there's my original one. Now I'm gonna do my transformed one. So I'm gonna move up a little bit. And see how I get the whole number. So -3, -5. So down left 3, down 5, right here. -2, -4. -1, -2. 0, 2. 1, 10. When you look at that, you can see how steep that is. So it comes like this, and it's going to bottom out. And even though the calculator eventually errors out and says -6, it never hits -6. So what happened on this one? Well, you can see the blue one is left of the green one, and it actually is left 3. And also you can see that it moved down 6, and we get that from right there. All right, so transformations. The translation, which is shifting, that's moving it, left, right, up, and down. Reflection, which is flipping, and or dilation, stretching it. These are all the things we're going to do to it. Okay, so the A value, this A right here, what that does is it tells you if it is stretched vertically, compressed vertically, or if it's negative, it's flipped. So the A value tells you these 3 things. 1, 2, 3. All right. The H value right here shifts it left and right. And we're going to learn this phrase, inside lies. So when you see -5, you think left, it's actually right. And when you see +2, you think right, but inside lies, so it's left. And if you look back here, you'll see that. This was a +3, but it moved left. This was a -4, but it moved right, and so forth and so on. And then K, this number here moves it up or down. This is the one that doesn't lie. Positive is up, and negative is down. So for this one, left is actually positive, and right is negative. It's opposite of what we think. So without graphing, without using our graphing calculator, we're going to look at this. Okay? This 3 out here is positive. It's bigger than 1. I'm sorry, bigger than 0. So it's going to stretch it vertically. This +4 inside lies, so that's left 4. And -8 is down 8. All right, here's my negative. So right off the bat, we know that's flipped. Inside lies, so right 5. And +3 means up 3. Now, here we have a negative, so we just got flipped. We have a 1/3. 1/3 is between 0 and 1. So it's compressed vertically. Inside lies, so instead of moving right, that moves it left 10. And +1 means up 1. All right, now we're going to graph it, list everything we can about it. Okay, so we're going to go here. Now, what I said before still stands. I highly suggest, so you see what's happening. You see it's an absolute value. Just go to math and do absolute value of x. And do the transform in 1 second. I promise you will make your life easier. So we go over here, math, absolute value. We put in x + 6. Come outside of it, +1. Now we're going to hit graph. So there's my v. Now notice my V got thinner. That's another way of putting it on some of these. Now lines you can't say thinner, and cubics you can't say thinner, and that's where we do the stretching. But on this one, I would be fine if you said thinner, because it is stretched vertically. It's getting thinner as you pull it up and pull it down vertically, okay? It's also moved to the left, and it's moved up. You can see the vertex is just above the x-axis. So where did that start? So we're looking at the third column. So we're looking for the 1. That's the bottoming out part. You see where it says -6, 1? That's where it bottoms out. And then you can look at the graph, but it's really easy. Here, well, no, sorry. It's stretched, so I can't just do that. So -7 is 3. So instead of going up 1, it goes up actually 2. So -7, 3. And then -8 is 5. So it jumps up 2 every time. So same thing over here, right 1 up 2, right 1 up 2. And there is our function right there. Okay, it is absolute value. And you can abbreviate like that. The domain, it's going left forever. And it's going right forever. Now, how low does it go? It bottoms out at 1. And it includes 1 because it hits it. And it's going up forever. Now, what's happening? It's thinner or vertically stretched. It is inside lies left 6 and +1 up 1. All right. Next one, we have a quadratic. So I'm going to clear out what I got. And I'm just going to put in a quadratic, the parent function. So x squared. And then my second one, I have the gray negative key. I have parentheses, x minus 5. So you should be thinking about what's happening to this already. It's going to flip over. We put the little square there, and then -3. And here's our parent function. And here's our new one. It's right, down, and flipped. Okay, so where is it topping out? It looks like, 5 or 6 maybe. So you see how the -4 repeats? So the 5, -3 is where it tops out. So 5, -3, right there. And then it is 4, -4, and 6, -4. And then it is 3, -7. And that would be 7, -7, because it matches, it lines up. And then we have our general shape like that. That's good enough. What is it? It is a quadratic. Again, it is going left and right forever. Now this time, it's going towards -infinity. That's how low it goes. How high does it go? -3. And it includes that, so we use a bracket. Sorry. Now what's happening? Well, right here, it's flipped. Inside lies, so right 5. And if you think about where the parent function would be, it'd be like here. So right 5. And then the -3 does not lie. It's down 3. And you can clearly see this is down. All right, 1/2. This is exponential, but this is decay because it's less than 1 to the x minus 4. So in my y equals, I'm just going to use 0.5 instead. So 0.5 to the x. And then 0.5 to the x minus 4. Notice I'm just keeping it up here. Now I arrow right to come down for the minus 6. Now the x minus 4 is not in parentheses, but for all intents and purposes it is. So you can still think about inside lies. So there's my parent function of decay, and you can see that it's moved right and down. Okay, so let's get some points here. Maybe. There we go. So you can see it starts getting closer to -6, and it's getting a lot of decimals. So we're going to go with 4, -5. Three, -4, 2, -2. 1, 2, and 0, 10. And there we go. It bottoms out as you get close to -6. So I always go the opposite direction and try to bottom out as close as possible. So this is exponential decay. The domain. Now, it doesn't look like it's going straight up, but it's not. It's going slightly to the left forever, and it's going right forever. Now, how high does it go? Positive infinity. Now the tricky part, how low does it go? -6, but we use a parentheses because it never hits the -6. So what happened? Inside lies means right 4, and this means down 6. All right. Last one. So we have a square root function. So I'm going to clear this out. So for the first one, I'm just going to put y equals second square root x. For this one, 2, second square root, underneath x minus 2, hit right to come out of it, plus 1. Whoops. So here's my square root function, and there is my transformed one. Now you notice the angle of the curve is a little bit different, okay? So that's where we call it stretched vertically. That's when that's 2 there in front. So let's get some points. So we actually have 2, 1, and 3, 3. Let's see if we have any other whole numbers down here. We have 6, 5, and 11, 7. So 6, 5, and 11, 7, which is just going to be a little bit off there. And that's our function right there. So this one is a square root. Now, how far left is it going? Let's look back at our calculator. Notice we have the error at 1. So how far left? I went too far when I did this. It's right there at 2. And there's a point there, so we use a bracket. And then it's going to go right forever to infinity. Now, how low does it go? That's right here. It bottoms out or starts, if you want to think about it that way, as 1. And then it goes up towards positive infinity forever. Now, what are the transformations? This 2 stretches it vertically. Thinner doesn't really apply to a function like this. Doesn't really make sense, thinner or wider. This inside lies, so right 2, and outside is truthful, so that's up 1, and we are finished.